do question 25. 25. You have a weight of 7 newtons. Hangs vertically by two strings, A, B, which is indicated by tension 1 with an angle of 35 degrees. And AC, so this is AB, which is indicated by tension 2 with an angle of 50 degrees. A weight of 7 newtons hangs vertically by two strings, AB and AC, as shown in figure 25, for the weight to be equilibrium. Again, what are the criteria for equilibrium? In this case, equilibrium is cause the object either to be at stationary or to be at constant velocity. In this case, it's quite obvious. We're looking at a stationary case again. The tension in string AB is T1 and the string AC is T2 on figure 25. Draw a vector triangle to determine the magnitudes of T1 and T2. Okay, in this question, there's two ways to answer this question. One is to draw a scale diagram. So, in this case, we've got 7 newtons here, and this is question A. So let's say you use the scale diagram. So what I need to do, first of all, choose your scale. 1 centimeter is to be 1 newtons. And what you get is you're going to draw a line that is 7 centimeters long. After that, you're going to draw a line as long as you can go to be indicating T1 to be 35 degrees. And if we draw it here, up to the angle is 50 degrees, you now draw another line, T2 at 50 degrees here. So this one will be T1, this one will be T2. All you do is measure the distance apart, and if you got an eraser, you just remove the unnecessary components because you're using pencil to draw a triangle. And then all you need to do in this case is state your T1, T2. Okay, so this is the scale diagram method. Another way to do it is to resolve the forces. So A2, we're going to resolve forces. As usual, let's say we take positive to be positive, upwards to be positive, resultant force equal to MA because it's stationary. This one is equal to 0. Then we got T1 cos 35 degrees, which is positive, plus T2 cos 50 degrees, which is positive, minus 7 newtons. You got one equation. Now you have the next part. Let's say you choose this one to be positive here. Resultant force is equal to MA. This one is equal to 0 because object is stationary. Now we got T2 sine 50, positive T2 sine 50 because it's in the same direction. T1 sine 35 is in the opposite direction, so minus T1 sine 35 degrees. And these two will balance each other off. Therefore, 7.0 newtons is not involved because it's only sitting vertical and not horizontal. With this one, you can then decide, let's say you want T1 to be the subject. So put this on the other side, you got T1 sine 35. Here you have T2 sine 50. So your sine 35 will go back down here. So this will make a T1 subject, sine 35. All you need to do is then put the T1 back into this equation, and then you'll be able to find your T2 value. After you find T2 value, then we'll reinsert it into the T2 value here. You get your T1 value. Okay. This one is resolving forces. You end up with a simultaneous equation. in both cases. I'll let you calculate, you pause the video, and then your value should be around this. So T1 will be around 5.4 newtons, T2 will be around 4.0 newtons. So now you have two diagrams. You can use scale diagram, two techniques, use scale diagram or resolving forces technique. Now comes the question. By reference to the figure, suggests why the weight could not be supported with strings AB and AC both vertical. Very interesting question. It is asking if you have 7 newtons here, why can't your AB and your AC be vertical? Okay. And you already know why it cannot be vertical, because when you have AB and AC vertical, these two forces balance each other. Therefore, yes, on the horizontal component, it is indeed stationary. But you notice there is no forces that is balancing it at 7.0 Newton. There's no brake forces. Hence, this one still exists. Hence, the object cannot be in equilibrium. But sometimes we don't answer. But problem is, how do you put it out? So let's have the answer in word format. Forces in strings would be horizontal. So the forces in string AB and AC will be horizontal, which is stand here. So no vertical force to support the weight. So this is the answer that they're given. But it is you how we write this in the way you understand. Quite easy. Let's say if you don't know what to write, and I always say this right or this right. Here, force AB is at an angle, so you can just easily straightly write down there. Force AB is horizontal. Force AC is horizontal. But W or weight is vertical. Therefore, no upwards vertical force to balance weight. So sometimes when you look at markings, it might not be easy to understand. So why not write it in your format and double check it's correct? In this case, yes, we did mention the strings AB, that's why we say AB, AC. We did mention they're both horizontal. We did mention that the weight is vertical. We did mention there is no upwards vertical force to balance the weight. Therefore, you can also write it in a simpler way. So I hope you understand this video. If not, please replay this video.